to record so I can see. There it is. Blurry. That should be better. All right. How's your homework coming? Pretty good? Everyone's ready for your test? Hopefully.
When's our test?
Friday. So we got I squared plus 3 minus 7 plus I cubed. Right. And it says to write this in standard form, a plus bi. So let's see, some things we could do here. I squared is -1. -1 plus 3. And then we could distribute that negative to minus I cubed. So this and this becomes 2. Check me on that. And then I cubed could be written as I squared times I, right? So I squared is a -1, which makes that a plus. And so 2 minus 7 is -5 plus I. So hopefully that's good. I don't remember who asked for that one. So any other homework questions that we didn't get to yesterday or you want to ask today?
Yeah, how do you do number 23?
On the same page, 57?
No, I'm 58.
58. Let's do 58. 23.
Yeah.
MJ's number. Yeah. Number 23. Find the real number x and y that make the equation true. So in 23, we got 5 minus 2i minus 7 equals x minus 3 plus y. So the idea here is to write both of these in standard form and then equate real part and imaginary part. So this becomes 5 minus 2i minus 7. 5 minus 7 is -2. So I just wrote it a plus bi. And over here, same thing, distribute that negative. So x minus 3 minus and can't really do anything here, right? So what we would do is see this being equal to this and seeing the imaginary part equal to the imaginary part. So then you're going to have x minus 3 is equal to -2, right? This piece has to be -2. And your minus yi has to be equal to minus 2i. And then you solve for x and y. So x would be 1, and it looks like y would be 2. So hopefully that made sense.
Yeah, thank you.
We got it. Good. Any other homework questions before we move on to notes? I will be putting you guys in your groups today. there's no more questions, let's go to the notes. Go ahead and work on that warm up.
Mr. Garcia,
Sure.
sorry for being late the first 10 minutes. I couldn't log in.
Oh, no worries. All right, you guys done? Hopefully. What did you guys get for this?
I got 5 minus 27i over 13 plus 3i.
So you got 5 minus, that's all I remember.
Do you need me to resay it?
Yeah.
5 minus 27i over 13 plus 3i.
13 plus 3i. Okay. Anyone get something different?
I just got 13 on the bottom instead.
So almost
So like no 3i on the bottom.
like that.
Yeah.
Okay. Anyone else? All right, so we do 1 times 5, you get to 5. 1 times the 2i, you get to 2i. This times this, it's minus 5i. This times this, it's minus 2i squared. All over 2 plus 3i. So this is a negative 1, which makes that a plus, which gives us the 7. And 2 minus 5 is minus 3. And then when we're dividing by this, we have to multiply by the conjugate. That would give us what? 14 minus 21 minus 6 plus 9i squared over 2 times 2 is 4. Right, distributing. But then the middle terms go away because you would have minus 6i and plus 6i, and then a minus 9i squared. I squared is negative 1, which makes that plus. So 9 and 4 is 13. I squared is negative 1, so that's minus 9. So 14 minus 9 is 5. And minus 27. So I think this is correct. So be careful with this. Maybe you lost something in the distributing here. So no worries, good job. So now we're going to solve these equations like we've been doing, but now we're gonna actually switch to solving inequalities. So it's very different. So I'm gonna send you guys to your breakout rooms. So I want you to discuss this problem. You can write it quickly, or if you open up another screen on your computer, I did post this in Google Classroom. So you could go to today's PowerPoint and get to this slide. But I want you to discuss in your groups, what does it mean to solve an inequality, and then solve this inequality algebraically and graphically, and you can use Desmos or a graphing calculator. So absolute value of x minus 4 is less than 8. And I'm gonna send you to groups, and when you're done, I'll call on a group at random to share what your answer is for this. All right, sounds good? Hopefully. Everyone's asleep. Can I get an amen?
Amen.
There you go.
Amen.
Right on, right on. Now you're waking up. Did you guys not see a button? Or are you copying the problem? Christian, Natalie?
What happened?
I only see you.
You didn't see a button to join a breakout room?
No.
Hmm. work. Let's Christian, right? Oh, it's awfully quiet in here.
We just typed it up.
And since the lines are like freaking dash, huh?
Yeah, so it's not equal to or less than or something. Yeah.
How you guys doing here? Any questions?
We're just a little confused on how we get the like second one. Because on Desmos, we got the graph where it makes a little section, which is supposed to be like x is less than 8, and then x is greater than -4. And we got x is less than 8, but like, we're just having trouble with the x is greater than -4.
Okay.
Mm,
So maybe think about the definition of absolute value. That might help you. So you can rewrite that absolute value.
oh, okay. Mm,
So think on that.
I just got this big old block on my graphing thing. Hector, did you get the same thing as me?
I'm already done again, but
I already did. It's the same.
I had a block. I had a block too. That's why I was like a little confused. But
I put the exact thing.
let me see. X.
How's it going here?
Good.
Good, actually.
Good.
What we did was, this is absolute value. We turned it from x minus 4 to x plus 4 is less than 8, and then we added 4. I mean, we subtracted 4. And then we got x is less than 4. We graphed it, open circle, the x is going to the left. Or the line is going to the left.
All right. Then just verify, make sure your solutions match. So like your solutions make that inequality true. But sounds good. How are we doing in here?
Good.
You guys have a solution?
Yes.
Yeah, all right. Very good. How you guys doing?
So we're graphing it on like an actual graph or like a number line?
The way I've been teaching you, right? So left side is a y, the right side's a y.
Yeah, so I mean, I got x element of -4 and +12.
So your solution sets from -4 to 12, okay?
Yeah,
And Karim agrees.
Yeah.
Yeah. All right, sounds good. Did we get everyone back? I hope. Looks like it. All right. So let's go ahead and randomly pick number 1. That was random. Anyone group number 1, you want to share what you came up with?
What we did was we turned the x -4 to x +4 because of the absolute value. And then we subtracted 4 from both sides. And we ended up with x as less than 4. And once we graphed it, it's an open circle and the line is going to the left.
X is less than. So you graphed it on like a number line?
Yes.
Okay. Open circle to the left. And hopefully you verified your answers. So any number in there should work, correct? Okay. What about group 3? That would be Karim or Giovanni.
Oh, so I got x element of -4 and 12, and I did that by doing -8 is less than x -4, which is less than 8, and then I just added 4 to both sides. And then because it's x element of, so x is any number within the set of between -4 and 12,
Between -4 and 12. Okay.
but not being them.
Right. So you'd use parentheses. Okay.
Yeah.
And did you try graphing it?
On a number line, you would just do like both open circles, and it would be like a line segment from -4 and 12, and anything inside that is x.
Okay. And for the sake of time, I'll just ask, did anyone graph this in Desmos using X and Y, 2-dimensional?
Yes.
Thea did. Okay. And from that, what was your solution after graphing it?
The solution would be x is less than 8 but greater than -4. That's about it.
X is less than 8 and X is greater than -4. Okay. So let's see here. What's that? Let me stop sharing that. Let's just bring up Desmos here. Let's see what we're talking about. So on the left, what did I have? It was absolute value X minus 4.
Yeah.
And on the other side was an 8.
Mm-hmm.
Maybe I need a Y equals. There you are. Okay. So I don't know how to flip back and forth, guys. Sorry. So the equation was the absolute value of X minus 4 is less than 8. And so here is the line where Y equals 8. And so I want the function, absolute value of X minus 4, to be less than 8. So I want all these numbers down here, right, that are below that blue line. So if you look at the X value, what do you see? -4. And if you look over here on the right side, what's the X value? +12. So any X between -4 and +12 will give me values that are less than 8, which is that blue line. So that's kind of what I'm hoping you take away from this. I've been trying to show you to look at functions the last few days. Where you see an equation, you think of the left-hand side as a Y equals whatever function's on the left. And then you see the right side of the equation as another function, Y equals the right-hand side of the function. So here we have Y equals 8, the blue line. We have Y equals absolute value X minus 4, it's the red function. And the inequality says left side is less than the right side. Well, less than, when you talk about Y values, is below. So anything below that blue line would be a solution. So all the X values that give us the Y values less than 8 are between -4 and +12. So hopefully that discussion made sense. Because it's not too difficult, not too difficult. So good job, thank you for that. So then the rest of the period, here's just some more examples. So this would be similar to the one we just did, right? But pay attention to the inequality. I'd like to do the second one with you, and then for the time remaining, I'll throw you back into your breakout rooms so you can do the other 3. So let's just look at x squared minus x minus 12 greater than 0. And I think I'll do that one here. Whiteboard. So x squared minus x minus 12 greater than 0. All right. Okay, you guys see the whiteboard there?
Yeah.
Yeah.
Yeah, all right. So you're gonna have to do questions like this in the homework, where it says solve this. So in Algebra 1, Algebra 2, we're used to this being an equal sign. So we could say if, right? If this was x squared minus x minus 12 equaled 0, what would we do?
Factor and then solve for x.
Factor and solve for x. You're all experts. You did this for 2 years. 4, 3. That's negative, so I need -4, +3. So from this, we know that x would be -3 and 4. And I always tell you, so what? What does that mean? Well, that means when x is -3, I get 0. That means the y is 0. So that's your y-intercept, right? Or x-intercept, sorry. So if we graph this real quick, we have a x-intercept at -3 and an x-intercept at +4. So hopefully we're okay with that. And if you go back and look, we could also think of these as functions, which is what I've been trying to show you the last few days, right? The left-hand side could be y equals x² minus x minus 12. And the right-hand side would be y equals 0. So now you have two functions. So y equals 0 is the x-axis. I'm looking at the x-axis. And this other function is a positive quadratic whose x-intercepts are -3 and 4. So we know it's going to open up like this. And so with that, I would say we can now solve this problem. Because if you go back to the original question, they want to know, when is this function greater than 0? Well, that would be all of this. So this function's y values are greater than 0 for this piece of the function and for this piece of the function. And so you're experts from what I taught you 2 weeks ago. We can write this as an interval, right? So we don't care about this piece. That's when it's not greater than 0. So this piece goes all the way to -infinity. And this piece starts at 4. It goes to positive infinity. So these are the x values that give us positive y values. And that's what we were asked to find. When is this function positive? When is this function greater than 0? This function is greater than 0 or positive above the x-axis. So we found the parts of the function where it's above the x-axis. And these are the x values that give us that piece of the graph. So from -infinity to -3, the function's above the x-axis. From 4 to infinity, the function's above the axis. So that would be your solution. That makes sense? Hopefully. Okay. So with that, I'll kick you back to your breakout rooms. To see the problems, like I said, if you open up another window and go to classroom, you can open up today's notes and see the problems. I guess I could present that real quick so you could see it if you want to just jot them down. So there they are. So I just did the top right. So there's these other 5 that you could work on in your breakout rooms. If you get stuck, I'll jump in between to help you guys out. Oh, I didn't change that. That's okay.
Wi-Fi disconnected momentarily.
Yeah. Trying to put you back in there.
Cheers.
I put.
Mr. Garcia.
You didn't show us how to write it down. You just said it. But
Mr. Garcia.
Yes, sir.
So, okay, when I go on Desmos for the 3x, the absolute value of 3x minus 2 is greater than or equal to 5.
Yeah.
I get that x is in between the points -1 and 2.333. So how would I write the answer down?
You could write it as a interval notation.
Oh, so I can put
-1 is less than or equal to x is less than or equal to 2.3.
wait, how would you interval notation?
Right? Parentheses, brackets.
Oh, okay. So bracket -1 and then open on 5.
It'd still be a bracket because this is
Oh.
greater than or equal to, right?
Yeah.
But you're kind of scaring me because since it's greater than or equal to 5, I think infinity would be involved.
Wait, I'm so confused now.
Would it be bracket -1 comma infinity, and then bracket wait, never mind. Negative infinity, -1, and then 2.333 comma infinity.
Maybe. Are you guys graphing this in Desmos? Two different functions?
Yeah, I graphed that in there.
Yeah, so it would be negative infinity, -1, right?
So it'd be
Yeah.
parenthesis, negative infinity, comma, -1, bracket.
And then the second one would be bracket 2.33 comma infinity parenthesis.
There you go.
Okay.
Now you got it. Good. Keep working on those.
Wait,
My dogs are barking now too. Oh my god. This is too much for me to handle.
Give them a treat.
I'm struggling. Oh god.
I think I got one of the answers.
Oh my god, I'm on mute. Okay.
Roberto has an answer.
I think so.
Which one were you doing?
2x squared plus 3x is less than or equal to 20.
Okay. Graphic?
Similarly to how you graphed it, I think. I didn't use like Desmos or anything.
Oh, okay. I was gonna say, did you put those into Desmos?
Nah, not yet.
Okay.
I probably should though.
Well, it's just a good way to check. But remember, put the left side into Desmos, put the right side into Desmos, look at where they intersect, and then pay attention to the less than or greater than. It's that easy.
Alrighty.
So good job. Keep working on that.
All right.
How are we doing in here?
Good.
Jazzy says good. No questions?
Nope.
You guys are like talking to each other?
We're solving them.
Oh, okay.
Towards 0.
Oh.
Okay. And I'm pretty sure we just did the same thing as the other one.
How you guys doing in here?
Good. We just solved the first one.
So you did the absolute value 3x minus 2, that one?
Wait, which one? We're doing the first one of, after the one you did, we're doing the next one.
So you did 2x squared plus 3x? That's the one? Okay. You graphed it on Desmos?
Well, yeah, and we got negative infinity, -4, and then that U symbol in the middle, and 5/2 positive infinity.
Okay, sounds right. Another group said it was 2.33, but 5/2 is 2.5, so you guys are close. So I don't know if there's a difference in Desmos, but right on. All right, keep it up, keep it up. Vanessa, how we doing in here? Vanessa's not there. Jasmine, Isabella,
I'm still working on it.
still working on it? Okay. Any questions?
No, I'm okay.
How you guys doing in here?
Good.
Good. Pretty easy?
Yeah.
Right on, right on.
Sammy the Seal, I asked. Oh, Mr. Garcia. So when we graph the x cubed plus 2x squared minus 1, and then y is equal to 0, we get like this, like, it's still I think it's called a parabola. Still, I don't know, but it has 3 x's.
It does have 3 x's.
How do we write that?
Yeah, how do we write that?
Well, what x's are you looking for?
What do you mean by that?
You guys need to learn how to read math. Come on now, it's a language.
Oh, we're looking for the x's that are greater than 0.
Almost. You have
Greater than or equal to 0.
no. I said it in my example, right? Think of the left side as a y equals, think of the right side as a y equals. So you're looking for the x values that make those y values greater than 0. So essentially, if you think of the left-hand side as one function, where is that function greater than 0 or above the x-axis? So you want the x values that give you the piece of the function that's above the x-axis.
So, okay. So let me explain it.
Samantha, you go by Sammy or Samantha?
Whichever one you like.
Okay. What about Sam?
Yeah, it's fine.
So the left side is a cubic function, correct?
Mm-hmm.
So you're going to have 3 x's, 3 x-intercepts.
Yes.
Yeah.
So you're going to have what? 1, 2, 3 intervals, right? So you have one interval from a infinity to that first x-intercept. You have another interval between the 2 x-intercepts. You have a third interval from that x-intercept to infinity, right? Or maybe 4 intervals. 1, 2, 3, 4. 4 pieces. It cuts the x-axis into 4 parts, right?
Yeah.
So you're just listing the parts that the x's that give you the function above the y-axis.
So for us, well, Jace, would it be the -1 and then the 0.618?
Maybe. I wish we had more time. I'm looking at the clock and I don't want to keep you into your next period class.
Oh, would it be bracket -1.618 and then bracket -1?
If that gives you a little like a hump above the x-axis, then yeah.
Yeah, it does.
Yeah.
Then that's what you need because you want
And then the other one will be bracket 0.618 and then infinity open.
There you go.
Okay. Thank you.
You got it. All right, people. Hopefully you were starting to get the hang of it. We'll pick the discussion up there tomorrow.